so it goes from that 14,000 foot elevation down to about 4,000 feet over a period of 10 miles rather than over a period of 70 miles. So you get the steam up, they're compressed in much, much more narrow bands. And during the winter anyway, it was a very dramatic period of rain. During the summer, it just looks like more dry brown rocks. Still dramatic enough, especially when it has snow. Okay, first of all, I want to point out that a miracle has occurred. This slide is absolutely not in mirror image, so that almost never happens. So this is what it really looks like. So this is Yosemite Valley, and what I'm trying to show you here is that right here is about 4,000 feet off the Yosemite Valley. Below that, the valleys are V-shaped. This is a river-carved valley, but above that, they're U-shaped, massive glacier-carved valley. So glaciers came down from the Sierra, following the river valleys, sort of bulldozing them out, making them broader, steeper sides, and then they just wasn't wet enough, wasn't cold enough, they couldn't get beyond that, and they stopped. And when you drive up, this is going up through the El Portal entrance into Yosemite. It's really claustrophobic in the River Valley part. You find the same thing if you go to Kings Canyon National Park. You drive up, well, you go up through Grant Grove and down that windy road, down by Boyden Cavern, and then you go up the road, and it's just really claustrophobic. There's a river valley, railroad track that's been abandoned, and then the road, and that's all the roof in the bottom of the valley. And then it's just steep V-shaped valley until you get just past Cedar Grove Campground, and then it's the same. It just opens up in a broad V-shaped valley, and it's much valley. Unless you like to be compressed, it's a much nicer feeling. So the U-shaped valleys are indicators of, this is what happens when you crash your car. And it turns upside down, like that. Okay, so this is looking at Yosemite Valley past that V-shaped part, so you can see the flat bottom. And with Yosemite Valley, the thing called the terminal moraine, a pile of gravel the glacier shoved up, actually formed a dam on the river. And so there was a lake in Yosemite Valley, and that made the bottom of it even flatter than the other ones, because it silted up with mud and sediments and stuff. And then the river cut through the moraine, and now it's what it is now. One thing to notice on this is the backside of half dome. So granite domes we'll talk about in a little bit. There's a dome here, a dome here, the domes all over the place. We'll talk about how they're formed. So now we're in Yosemite Valley in mirror image. This is reverse right to left. And what this picture is trying to show you is here where Bridal Veil Falls. Again, it's a U-shaped valley, and this is called a hanging valley. So the side walls of a glacier-carved valley are valleys when this was filled with ice. That big glacier right here. And so the tributary glacier comes down and feeds into it up on the edge of the wall. Whereas a river-carved valley is going to cut through it at an angle down to the river. And we'll have hanging valleys. Anytime you've seen hanging valleys with all these dramatic waterfalls, that's again glacier features. This is Yosemite Valley over here. This is what they call Little Yosemite Valley, and this is showing you what are called cirques. So as the glaciers come and go and melt, they start in various places. And so there's a glacier that originated here, and then it was hanging valley there, obviously the waterfall, merging into another glacier here. And then it melted and it dropped down in elevation, so then the surface of the big glacier was right about here. And this glacier merged into it there, and then all that melted, and there's another waterfall. And that happened one more time, but you can't see it down here. So it's like a stair step of different glacial elevations based on when they were formed and how much ice there was in the main valley. This is where those, I think it was this Nevada Falls right here. That's where those guys fell into it. Last summer, was that last summer, right? They fell into the water and disappeared, aka drowned. Couldn't find them for a long time. Just Bridal Veil Falls up close and personal, nice hanging valley, and it's U-shaped. You kind of see a little notch being cut in here, so the water is working on making it a V-shaped valley. And it takes, I don't know how long it's going to take to cut through. That's a lot of granite. There are this is what's called glacial polish. You see the shiny places on the rock? And as glaciers move, they pick up sand and silt, grit of various kinds, and it acts like sandpaper. So just like taking sandpaper, think that will ruin the finish of wood, but if you rub it on the wood, it smooths it out and shines it up. Same thing that with small particles move across the rock and shine it up. Originally, much more of this dome would have been shined, but parts of it have weathered off over the last 10,000 years or so, so that's what the non-shiny areas are. That's glacial polish. When you get up there and look at it, it looks like this. And the sun has to be on it pretty much just at the right angle to see the shine, but you can definitely see it looks like it's been polished. You can also see these lines stretched, which are called glacial striations, and they're caused by bigger rocks being embedded in the glacier. So first it shines it up with the small pieces, the glacier goes across it and scratches up that shiny surface. Okay, and they're all in parallel rows, so that's what you'd expect from a moving glacier. And it's pretty slippery, so if you're climbing on it, you need to pay attention to it. Move a little more cautiously. It's not terribly slippery, but it's slipperier than the weathered rock, for sure. Glacial erratics. I said that glaciers pick up big rocks and move them. So these rocks here, this is something you'd normally never even think about. You just look at this and say, yeah, so there's rocks sitting on top of rocks, big deal. What's unusual about that? So what's unusual about it is if you're standing here, there's nothing higher than this that the rocks could have fallen from. So somehow these big rocks got set down here. Your choices pretty much are the glaciers did it or aliens did it. Nobody really believes aliens did it. So what happened is when the glaciers were moving from over here someplace, rocks fell down the slopes, landed on the glaciers, or they scooped them up out of the ground and embedded them in their bottom surface. But eventually the glaciers melted, and any rocks that were embedded in them just got dropped wherever the glacier was. So all these are rocks moved by the glacier called glacial erratics. In mountain glaciers, it's not such a big deal. They're the same type of rock as the whole thing is made out of. But with the continental glaciers, like places like Iowa, you can find glacial erratics across Iowa that came from 1,000 miles farther north in northern Canada. And they're geologically different than the local rocks. And then the next thing here is about domes. Unfortunately, the day I took this picture, there was a forest fire, so it's all smoky. But you can still see the domes. A nice dome here. This is Tenaya Lake here, where you are. Yosemite. And some more domes here. I don't know what the domes' names are, but they're undoubtedly names. So the way domes are formed is that it's a combination of glacial activity and something called frost wedging. So when it starts off, this rock is covered up by other rock. And the weight of all that rock on top of it compresses it. It's like taking a dry sponge and squeezing it. So it takes it, puts it into a smaller volume. When a glacier comes along and it scrapes off all that stuff on top of it, then the rock starts to expand. And I'll picture this one here. So if you think about a big square chunk of rock like this, all the stuff on top of it, weighting it down, compressing it. Okay, so the glacier comes along and scrapes all that stuff off. The ice continues to compress it, weight of the ice, but that eventually melts. And then the rock is free to slowly start to expand. So these free edges start expanding faster than in here, because in here, this part's still compressed by the rock around it. So it's still under a great deal of weight. It expands here and here fastest. That results in little cracks. There's a curved fracture called exfoliation fractures, peel and bleed. And then it snows on this or it rains. Sun comes out, melts the snow, water seeps into the cracks. Night comes, it freezes, expands, presses on the crack to widen the crack. That happens over and over and over and over again for hundreds, thousands of years. So in that respect, it's a very slow process, but it's slowly widening those fractures. You guys see this okay, or I need to turn the lights on? Okay, so then one day, sun comes up, hits this thing, and the only thing holding the rock on now is the ice that's in there. So when the ice melts, you hear this big kaboom, and all of this stuff falls off. What was a square shaped structure now is starting to become a dome. And then that continues to happen over time, and the dome is slowly formed. And although they call it a slow process, it is a slow process. But the actual result of it is a very fast process. So when it falls down, it's not like, if you're standing there, you're going to get squished. It's a very rapid rock fall. And that happens in Yosemite on a pretty regular basis. Every spring, there's a number of rock falls in the valley or other places, just where the slow geological process has finally reached its culmination and something dramatic is going to happen. It also makes a really cool noise when it happens. It sounds like an explosion. I guess that's the ice letting go and the rock first starting to move. It sounds just like dynamite. This is just showing you exfoliation fractures. So once you're driving around in the Sierra, just look at rocks and you see these. This is good exfoliation fractures. Here's curved lines. But you can see how fractured that whole thing is from the unloading. It just starts cracking and water gets in